Today is the 23rd, and you are, bless you. I have 16 examples on my note card, and you might think, oh, well, goodness, that's a lot. But when they don't take but 30 seconds each, it's really not that big of a commitment. So let's talk about some square roots, just kind of the ins and outs, the basics of it. Before today started, I would assume if I'd walked up to any one of you and said, like, hey, what's the square root of 25? Like, you already knew that was five. What's the square root of 81? You knew that before this conversation started, right? So if I said to you, I want you to evaluate a square root, I will say I'll use the word evaluate when I want to know what like the actual numerical answer is. So like if I say evaluate the square root of 16, you say, oh, it's four. What we're going to be doing today is looking at square roots that don't come out nice. For example, something like the square root of 20. So you'll notice that 20 is not on your list, right? And again, you didn't need that piece of paper to tell you that. You all walked into today's class knowing that 20 is not a square rootable number. If I type it in my calculator and hit enter, it's going to be somewhere between 4 and 5. It's going to be 4 point something because it's above the square root of 16, right? What's the square root of 16? 4. And then above it on the roof side is the square root of 25, which is 5, right? So we know it's 4 point something. But that's not what today is about. Today is not about approximating a square root. I'm not interested in some decimal approximation. What we're going to learn today is how to simplify them. And it becomes sort of as commonplace as reducing a fraction or just doing any sort of other basic math that you've acquired. So here are the steps. It's a big day for me, Ellie, because if I mess this up, then the whole rest of their math careers are going to be shot, right? This is a big day. So I'm going to encourage you to follow these steps, and I'm going to do my problems. I'll kind of alternate back and forth because there are two different sort of visual ways to represent how we're going to do this. So method number one, the one that I've used for 29 straight years, is to make a factor tree. So what we're going to do is we're going to put branches off of the tree, and at the end of each branch, we solemnly swear that we are going to put two empty square root signs. I feel like I could say that 729 more times and there would still be someone stubborn who not draw them. So please put blank square root signs because it takes two square roots to multiply to make another square root. It's like any other factor tree you've been making since like fourth grade. So can you think of two numbers that multiply to make 20? Can you think of some more?
10 and 2.
10 and 2. So watch what I'm going to do and don't write it down because I'm going to do something naughty, bad. We all agree that 2 times 10 equals 20, right? Look, you probably don't need your sheet for this, but what's the square root of 2?
4.
Nothing good, right? 2 is not square rootable. It's 1 point something. It's garbage. It's trash. What's the square root of 10?
5.
Nothing good. It's 3 point something. It's above 9 and smaller than 16. I don't want these numbers. The moral of the story today is that when we're given a choice as to like, you don't have freedom of choice today. You don't get to pick the numbers. The numbers are going to choose for you. And when you have a choice to make about the square root of 20, you're going to pick these. You're going to put 4. I do want you to write this part down. 4 will go in the first one and 5 will go in the second one. Notice I've written 4 in red. That's a special number. What's the square root of 4? So the answer to the answer is 2 root 5. That is how you say that. It requires 3 words. 2 root 5. That is now in your arsenal. That becomes as common as any other basic skill you've acquired over the last X number of years of learning math. Now I'm going to rapid fire a bunch at you, and we're going to practice with this skill. Some of them are easier than others. So I'm going to start you out with 3 or 4 softballs, and then we're going to get to the ones where the numbers hide a little bit better. So here's another softie. Before we start, do you like the tree or would you like to see another way to do it?
I like the tree.
I'll show you the other way, but if you like the tree, then maybe that'll just be yours forever. Another way that becomes more useful as the radicals get harder, not necessarily in this class, but beyond, is to do it the sideways method like this, and to change the square root and to make it a little bit longer version of itself like this. I'll present both methods and I'll try to remember to treat them equally, unless I do this method and you all decide, heck with that, I like the tree, then we'll just use the tree. But what I commonly like to do with certain types of problems is take my number and just break it. And instead of making two separate radicals or square roots, I just make one and break the number inside of that one. Which way are we pretty sure we want to break up 45? Yes. And again, we could do 3 and 15, but 3's trash and 15's trash. So we're only going to pick numbers where there's productivity to be made or had. And so I'm going to take the 9 and the 5, and they're still both inside of, they're still in jail, we would say. That's what I would say. And then who's breaking out of jail? The 9. So what's the overall answer to this?
3 root 5.
That's how we say it, paid like a boss. 3 root 5. That's how you speak those words. Okay. So you can pick, and like I said, I'll try to remember to maybe go back and forth between the two different methods. Hold on a sec. So far, so good? Okay, let's go again. How about the square root of 200? You can experiment around today and try both visual sorts of ways. One root, 2 numbers inside, 2 roots. That's each one just kind of works for different brains. So what are the numbers I'm thinking of?
102.
40.
By the way, and Keith already said the right one for the record, but there are a ton of ways to multiply to make 100. 2 and 50? No thanks. Trash, trash. And when I say trash, I mean not square rootable, right? Don't pick numbers that aren't square rootable. Why would you do that? Right? You could do 4 and 50. This is going to be a lot of the kind of learning curve today is that, and I'll be really proud if you can answer this question. Don't write this down. But you'd be like, this is good because four's good, right? Can you see a problem with 50?
It's trash.
It's not trash. It's not that it's big. There's something else. Imagine you were a 4th grade teacher and you asked your students to reduce a fraction like 12 24ths. And you had a little kid in the back that went, I know, I'll divide them both by 2. Did I do it? Did I do it? And as a teacher, like out of one side of your mouth, you say, you did a really good job. But out of the other side of your mouth, you have to say, but you're not done. You see, there's more. There's still more meat on that bone. And so a teacher teaching his or her students how to reduce fractions would have to say, you didn't do anything wrong, but you're not done, right? That's how I feel about 4 and 50. Because I put myself in a position, and I'm going to come back to what Keith said in a moment, but you put yourself in a position with this where, look, the 50 would have to be treed again. And I never want to put myself in a position to have to make more than one set of branches, because what can 50 break down into?
25.
25 and 2. And my take on this, and I will teach it like this until they fire me, and it is, I want you / think you should do every one of these in one step. So 4 and 50 isn't wrong per se. It just makes the problem more work. So I'm going to go back to what Keith said earlier, and it is these 2 numbers are the ones we want. We want 102. We love those the best because the way I look at it is, yeah, I found a red number and that's rad. And I know it's perfect because the other number is at what we call a dead root. 2's got no meat on the bone at all, right? So what would the final answer to this problem be? Perfect. 10 root 2. Jackpot. All right, let's go again. The square root of 8. I'll do the sideways way for anyone that likes that method. So what are our numbers? So I'm going to put a 4 and a 2. What's the final answer? 2 root 2. Okay, I'm going to start stepping up, and let me give you one more softball. I got one more softball on the list here. 75. Root. If you don't draw the roots, people say things like this. This is what I have to put up with. And then I have to try to control my emotions when I talk to these kids who think that they're too good for following directions. They say, oh, I know the answer. It's 25 root 3. That answer's terrible. That answer just rips at my poor soul. So I tried throughout the year to not boss you around when it wasn't necessary. I feel in this case like it's necessary. Put the roots. What are the numbers we're going to put inside the roots? What are two numbers that multiply to make 75?
25.
If I have 75 cents in my pocket, I likely have 3 coins worth 25 cents each. Would you agree? You know, I love 25 because what's his square root? So the answer is 5 root 3. You guys okay back there?
Yeah.
Was that a hard one for you? All right. Coming. Is there? Oh, wow. Nice. No tienes que hacerlo. You don't have to do it. Si no lo quieres.
If I don't do it, then it's probably gonna be blamed.
Pretty much. I need two numbers that multiply to make 98. The problems are going to start to get more challenging now. They're not all going to be little fluffer puffers like, 20, 24, like, ooh, they start to get harder. And the numbers that I want you to find are going to hide from you. So it's at this point that you would, assuming that you brought your calculator with you, you're going to grab it and you're going to unsheath it. And I'm going to teach you a trick. It's called dividing by baby trash. Get used to this. So what I'm going to do, what you're going to do is you're going to type into your calculator 98 divided by 2. And the thing about 2 is what I call baby trash. 2 is of no use to me. 2 is the most worthless number because it's got no square root. I'm like, why would I waste my time? But something interesting happens if you divide 98 by baby trash 2. What is 98 divided by 2? Oh, so what I just learned is that 49 times 2 makes 98. The thing is, this is some basic number theory for you, like real fundamental. If you divide by little number, answer B, big number, right? And sometimes that big number is the one that we're searching for. What's the square root of 49? 7 root 2, final answer. Okay. How about this one? I've got no issues with the fact that those multiply to make 96. The only exception I take is that they're both trash, right? You'll find this a lot, that there are a lot of numbers that make 96, but I don't want them unless the first one is red and the second one has no meat on the bone.
48 and 2.
Again, I'll take it, but I hate it. Does 48 square root? Then I don't want it. So listen, the little baby trash trick doesn't always work. But you can divide by other little trash numbers. Trash numbers are like this: 2, 3. Is 4 a trash number? No. 4 is a square rootable number. It's not trash. You hurt 4's feelings. Who's after 4? 5. Is 5 trash?
Yeah.
Yeah. Is 6 trash? Yes. So this is where you just grab your calculator and you can just start dividing by stuff. And I heard you're about to say it. What is it? Who said it? Yes. If you grab that calculator of yours right now and you type in 96 divided by 6, 96 divided by 6, you will get 16. And I'm interested in that because 16 is red and I can square root it. And what is the square root of 16? 4. So the answer is 4 root 6. Sometimes kids will say, well, you can break down the square root of 6. And my answer is, okay, show me. What can you break it into? 2 and 3. Trash, trash, does me no good. Final answer. The combination of the sheet that is in front of you and the calculator that you always have with you, it's a very powerful combination when it comes to simplifying radicals. We use our calculator to do some baby trash calculations, and then we use the sheet to tell us when we've hit gold, pay dirt. Did you find it yet? What is it? It is. So 49 and 3. So what we learned from this is that if you take 147 and divide it by 3, the remainder, not the remainder, but the quotient is 49. Nice job. And what's the square root of 49? So the answer is 7 root 3. How about this one? I'm going to trick you with this one. What? Yes, the answer is just 8. So I wanted to throw this at you, and I'm going to throw one more of these at you before this lesson is over. I want you to be aware of the fact that not all problems require trees. It's sometimes entertaining to watch kids make a tree off of a number like that. And I'm like, what are you doing, kid? So watch out for numbers that are already rootable like that. Good catch. Thank you. This is a tough one. I mean, maybe. You guys have accomplished a lot this year. You're very good learners, so I don't think I'm going to be able to stump you like I sometimes have been able to.
12.
These are all numbers that work for me, but the only one that's any good is 16 by 3. Like one person said 12 and 4. And I get that your heart's in the right place because 4 is square rootable, but the trouble is 12 still has meat on the bone. 12's in a position like 12 sitting there waving at you going, oh, you got to break me down again into 4 and 3. I don't want to do 2 steps. And someone said 8 and 6, and that's just no good at all because 8 and 6, neither one of them is on our list. They're both trash. The only acceptable answer for 48 is to break it down into 16 and 3. And what is the square root of 16? 4 root 3 is correct. You can get there eventually if you want to take it, if you want to make it take forever, but I don't want to. Try this one.
96.
The first one you're going to want to say is 4 times 20. So I'll just beat you to the punch. Don't do that because again, 20 sits over there in the jail and says, I'm not done. I got meat on the bone. So go elsewhere. There's obviously 8 and 10, trash, trash. There's a winner.
Well, yeah.
Yeah.
I know. There it is. Jackpot. Cal figured out that if I divide 80 by 5, look up at the board, there's 80 divided by 5. My calculator tells me that the quotient is 16. And I'm going to keep drawing those good numbers in red because the reason they're in red is because they're our buddies. They're what we're striving for today. So square root of 16 is 4. So the answer is 4 root 5. How about this one? I kind of lied to you. I said I was going to do a lot of them the other way. I'm just not. This is what I like to do is the trees. So if you like the other way, feel free to do the one root thing. But that trees just feel so right. I don't know. So that's how I set up every problem. I draw 2 branches, draw 2 blank roots, and then I carry on with my day.
96 2.
You guys are saying things. Yes. And when you say things like 6 and 32, I have no issues with the fact that those multiply to make 192, but I hate those numbers with a passion. And today's lesson has been a failure if you don't understand why. What's the square root of 6? It ain't happening. What's the square root of 32? It ain't happening. It's trash. I don't want numbers that you just come up with because you feel like it. I want numbers where progress is made, full progress. There are a lot of pairs that make 192, but Josh was the only one to throw the correct one out. He figured out using the baby trash tactic. I'm sure what he did is he took his calculator and took 192 and tried to divide it by 2 first. And then he figured out that that's going to be 96. And he's like, oh, look elsewhere. 96 is no good. What's up?
Something that Manwell told me last year, if you add all the numbers together, this will go like 3.
Right. It's a divisibility test, right? So like you can just take 1 plus 9 plus 2 is 12, right? But I mean, if you got a calculator handy, but I love that divisibility test. What Josh figured out is, hey, if I could divide this by 3, let's see what happens. You know, YOLO, 192 divided by 3, and then his calculator pops out this beautiful gem. Boom. You're like, I love 64. What's the square root of 64? So the answer is 8 root 3. By the way, that test also works for 9, Josh. That adding test works for 3s and 9s, but only those two. But it's a good one. All right, this one's going to kick your booty. Are you ready? I'll pour some coffee while you search. The trouble with 28 and 4 is that I love 4, but I need you to be able to look at 28 and determine that it's not trash. If this is so 4 is why Cal said 28 and 4 is because 4 is good, right? And I did hear the right answer, by the way, back there a while ago. Was that you? Just FYI. But the trouble is I never want to leave more work to do. So 4 and 28 aren't wrong per se, but the winner came early on from the back of the room, and someone figured out that if I divide 112 by 7, isn't 7 worthless trash?
Yeah.
But look what it produces. 112 divided by 7 is 16, and 16 is beautiful. What is the final answer? Jackpot. Let's go again. I won't need much time. You're going to get this one fast. Boy, that was, I didn't even have time to draw my roots. You were so fast. Nash figured out if I divide 108 by 3, I get 36. Oop, I didn't draw it in red. I hate that. We're almost done here, Peyton, I promise. And then square root of 36 is 6, so 6 root 3. This one will whop you. Yeah, you didn't even, that's twice. I can't fool you guys, right? The square root of 144 is just 12. No need to make a tree. How about this one? 3 times 7 is 21. 21 and 2 do me no good because 21 is not square rootable and 2 is not square rootable. As I said, I just don't want the first numbers you think of. I want you to have taken the time to say, is one of them red? 7 and 6 are trash. 7 is not rootable. 6 is not rootable. Trash and trash.
14 and 3.
14 is trash and 3 is trash. You're giving me every pair of numbers that I would expect you to give me. If you looked on your factors pair sheet that I gave you a month or so ago, you would see 2 times 21. Do we like it? No, they're both trash. Why would we pick that?
6.
We would, next up the line, we would go to 3 times 14. Do we like it? Trash and trash. Next up, the only one left is 6 and 7. Do we like it? No. Therefore, the answer is the square root of 42. So in addition to numbers that can be broken down, and in addition to numbers that are already square rootable, you might occasionally find a dead root just out there in the wild. 42 is a perfect example of a dead root. No progress to be made. Here's another example of a dead root, 30. right now, without using a calculator or a sheet, just you know this because you're in high school. Give me all three pairs of numbers that multiply to make 30. Go.
6 times 5.
6 and 5, trash and trash. 3 and 10, trash and trash. 15 and 2, trash and trash. Therefore, 30 is a dead root. So those are the three types of roots that you'll see. The kind where a tree makes sense and you work it out, the kind where it's just already rootable, and the kind where it's like, hey, you're dead. I think that I hit them all, maybe and then some. You guys have any questions? All right, your assignment is on the old Delta Math. I think I put 40 of these on there. I don't remember. It's a good place to start, but 30 or 40, I don't remember what I did. Got it? I will leave the recording on and paused. And someone might get one and go, hey, can you help me with this? And then I can add it to the recording if you want.